Hello and welcome. Have you ever wondered what truly lies in the deepest, darkest parts of the ocean? Not just the sharks and whales we know, but the secrets hidden miles below the surface in a world of total blackness and crushing pressure. That's exactly where we're going today. I'm going to take you on a journey down into the abyss to uncover 7 of its most incredible secrets. We're going to see a world that creates its own light, discover oases of life that thrive on what should be poison, and come face to face with creatures more bizarre and wonderful than any science fiction. And the best part? Everything you're about to hear is completely real. So get comfortable, maybe put on some headphones, and let's begin our descent. The world of living light. We hang suspended in the midnight zone, 1,000 meters below the waves. The concept of up is now just a memory of sunlight. The concept of down is a vast, unseen infinity. It is a darkness so complete that it almost feels like a physical substance. You might feel a primal urge to turn on a floodlight, to banish the blackness and see what's out there. But let's resist that. Let's just wait. Let your eyes and your imagination adjust to the dark. Patience is the key to the first secret. There, did you see it? A tiny, fleeting spark, like a distant star being born and dying in the same instant. And now another, a soft blue-green streak that paints a ghostly line in the water before vanishing. And another. Soon our eyes pick them out everywhere, a slow, silent, and constant ballet of light. This is the ocean's first and most magical secret, the pervasive, beautiful, and deeply functional world of bioluminescence. Down here, where the sun is a forgotten myth, life has learned to create its own light. It's not just a rare trick, it's the dominant language of this realm. It is used to find food, to attract a mate, to communicate, and to defend against the unseen things that share this endless night. Let's imagine the chemistry behind this magic, not as a dry formula, but as a tiny, internal fire. Inside the cells of these creatures, a molecule called luciferin, the light bringer, is waiting. When it's time to shine, an enzyme called luciferase comes along and acts like a matchstick. It introduces oxygen to the luciferin, causing a chemical reaction. But unlike a fire, which releases most of its energy as heat, this reaction is incredibly efficient, releasing almost all of its energy as a cool, gentle light. It is life itself, turning its own energy into a visual whisper. Look closely at that creature drifting past our viewport. It's a comb jelly, or ctenophore. It's almost entirely transparent, a ghost in the machine. But as it moves, its 8 rows of cilia, tiny hairs it uses to swim, refract our own submersible's faint instrument lights into dazzling, pulsing waves of rainbow color that chase each other down its body. It's an accidental light show, a byproduct of its graceful movement. But some comb jellies have a more deliberate display. If a predator bites it, it can release a flash of bioluminescent light. This isn't to fight back, but to act as a burglar alarm. The sudden flash of light in the darkness can attract an even larger predator, one that might be interested in eating the creature that just attacked the jelly. It's a desperate, brilliant strategy. If you're going to be eaten, make sure your killer gets caught. Now let's turn our attention to that string of glowing pearls drifting by. It looks like a single, impossibly long creature, but it's actually a siphonophore, a colonial organism. Think of it not as one animal, but as a floating city of thousands of tiny, specialized individuals all working together. Some individuals form the gas-filled float at the top, others form the long, stinging tentacles for hunting, and others are responsible for digestion or reproduction. Many of these tiny individuals are luminous, pulsing in synchronized rhythm, making the entire colony shimmer and glow. It's a glowing net, sometimes over 100 feet long, that drifts through the water, luring in and capturing small crustaceans and fish that are drawn to the hypnotic lights. And then, of course, there are the fish. The deep sea is home to the most ingenious masters of light. Let's focus on perhaps the most famous of them all, the anglerfish. The one we see is a female, a globular, strange-looking creature with a face that seems to be all mouth, filled with long, needle-sharp teeth. Protruding from her head is a long, fleshy filament, a modified dorsal fin spine, and at the tip of it dangles a small, fleshy bulb called the esker. This isn't just a lure, it's a sophisticated biochemical factory. The esker is filled with millions of symbiotic bioluminescent bacteria that she cultivates. She can control the flow of blood to the esker, effectively turning the light on and off, and she can wiggle it and twitch it to mimic the movements of a small, tasty creature. A smaller fish, seeing this enticing, dancing light in the vast emptiness, swims in for a closer look. And in a fraction of a second, the angler's huge jaw opens, creating a vacuum that sucks the unfortunate victim into its cavernous mouth. It's the ultimate ambush. But the anglerfish's story gets even stranger. The creature we've just described is the female. The male is a tiny, pathetic fraction of her size. He has no lure and his digestive system is rudimentary. His sole purpose in life is to find a female. He uses highly developed nostrils to follow the trail of her specific pheromones through the dark. When he finds her, a giant, luminous beacon in the black, he latches on with his sharp teeth. Over time, his body literally fuses with hers. His circulatory system connects to hers, and she provides him with all the nutrients he needs to live. His own organs, his eyes, his fins, all wither away until he is little more than a parasitic pair of testes ready to fertilize her eggs when the time is right. It is one of the most extreme examples of sexual dimorphism on the planet, a life of complete and total dependence, all brokered in a world of living light. Let's not forget the masters of defense. Imagine a small shrimp going about its business. Suddenly it feels the pressure wave of a larger fish moving in to attack. In a split second, the shrimp spews a sticky, glowing cloud of bioluminescent fluid from glands near its mouth. This luminous cloud acts like a flashbang grenade. The predator is momentarily blinded and confused by the bright, expanding light, its night vision ruined. In that moment of disorientation, the shrimp jets away into the safety of the surrounding darkness. This is a world where light is a smokescreen, a last-ditch effort to survive. The vampire squid does something similar, but instead of a cloud, it ejects a shower of glowing sparks from its arm tips, creating a confusing, starry spectacle that allows it to escape. Even camouflage is achieved with light. Let's look at the hatchetfish again, with its upward-facing eyes. From below, any creature would be silhouetted against the faint, residual light that filters down from the world above. But the hatchetfish has a trick. Its belly is covered in light-producing organs called photophores. It can precisely control the intensity of the light produced by these photophores to match the exact brightness of the water above it. This is called counter-illumination. The effect is that to any predator looking up from the true depths, the hatchetfish's silhouette is perfectly erased. It becomes a ghost hiding in plain sight by using light to become one with the faint light around it. This is the first secret. The dark is not empty. It is filled with a silent, vibrant language of light. A language of lures and warnings, of love and of fear. It is a constant, shimmering reminder that life finds a way to create its own sun, its own stars in the most profound darkness imaginable. the oases of fire and brimstone. We must go deeper still. We leave the world of mid-water hunters and glowing ghosts behind, continuing our descent till our sonar tells us we are approaching the seafloor. The pressure gauge on our console reads a number that is difficult to comprehend. The weight of miles of ocean presses in on our tiny sphere from every direction. The temperature of the water is just a few degrees above freezing. This is the abyssal plain, a vast, cold, and seemingly barren landscape. It feels like the end of the world. But the ocean floor holds a secret that completely rewrote our understanding of life itself. Ahead, our lights pick out a bizarre, almost alien landscape. It's not the flat, muddy bottom we might have expected. Instead, we see jagged, towering spires rising from the seafloor like the chimneys of a demonic underwater factory. Some are stark white, others are stained with oranges and reds, and from the tops of the tallest ones, a thick, billowing cloud of what looks like black smoke is gushing into the frigid water. We are approaching a field of hydrothermal vents. These structures are not rock in the traditional sense. They are built molecule by molecule by the very water that spews from them. The process begins deep within the Earth's crust. Here, at the boundaries of tectonic plates, the planet's crust is thin and fractured. Cold seawater percolates down through these cracks, sometimes for miles, getting closer and closer to the molten magma that lies beneath. As the water is heated to incredible temperatures, sometimes over 750 degrees Fahrenheit, 400 degrees Celsius, it undergoes a profound chemical change. The intense heat and pressure strip minerals and chemicals from the surrounding rock, sulfur, iron, zinc, copper, and hydrogen sulfide. This superheated, mineral-rich fluid, now much more buoyant than the cold water around it, begins to rise, searching for an escape route. It finds one at the vent fields and bursts out of the seafloor with tremendous force. The smoke we see is this scalding fluid hitting the near-freezing ocean water. As it hits the cold, the dissolved minerals instantly precipitate out of the solution, solidifying into tiny particles. The vents spewing iron and sulfur-rich fluids look like black smoke and are called black smokers. Those that are cooler and release fluids rich in barium, calcium, and silicon create lighter-colored, finer-grained chimneys, which are known as white smokers. Over thousands of years, these mineral deposits build up, layer by layer, creating the towering cathedral-like chimney structures that can reach heights of over 180 feet. The environment here is the very definition of extreme. The pressure is crushing, the surrounding water is freezing, yet the water gushing from the vents is hot enough to melt lead. The fluid itself is highly acidic and toxic to most known forms of life, rich in hydrogen sulfide, the chemical that gives rotten eggs their smell. By all logic, this place should be sterile, and yet it is not. This is the core of the secret. This place is an oasis. It is crowded, teeming, and thriving with life. Look at the base of the chimneys. They are covered in dense thickets of what look like strange, lipstick red flowers. These are giant tube worms, Riftia pachiptila. They are one of the most iconic creatures of the vents, and they can grow up to 8 feet long. They have no mouth, no eyes, and no stomach. They cannot eat. Their survival is a testament to one of the most beautiful partnerships in nature. The bright red plume at the top of the worm is not a flower. It's a complex respiratory organ, rich with a special kind of hemoglobin that binds to the chemicals in the vent fluid, especially the toxic hydrogen sulfide, and transports them safely through the worm's body. Inside the worm's trunk, in a specialized organ called the trophosome, live billions upon billions of symbiotic bacteria. The worm is essentially a living apartment complex for these bacteria. It acts as their delivery service, using its plume to collect hydrogen sulfide from the vents, as well as oxygen and carbon dioxide from the surrounding seawater, and delivering these chemicals to its tiny tenants. The bacteria then perform a miracle. In a process called chemosynthesis, they use the chemical energy stored in the hydrogen sulfide to create organic matter, sugars. It is a process that fills the same role as photosynthesis, but instead of using the energy of sunlight, it uses the chemical energy from the Earth's core. The bacteria produce enough sugar to feed themselves and their host worm. The worm provides the home and the raw materials. The bacteria provide the food. It is a perfect self-contained system, an entire ecosystem powered by brimstone. But the worms are not alone. Look closer. We can see swarms of pale, ghostly white crabs scuttling over the chimneys, navigating the treacherous temperature gradients. One species, nicknamed the Hoff crab after the actor David Hasselhoff, is notable for the thick mat of blonde, hair-like setae on its chest and claws. It's not for show. The crab uses these hairs to farm the very same chemosynthetic bacteria it needs to eat, waving its claws through the vent fluids to cultivate its own personal garden. There are also clusters of vent mussels and clams, their shells packed so tightly they form a living armor around the base of the vents. Like the tube worms, they also host symbiotic bacteria in their gills, filtering everything they need from the chemical-rich water. We see vent shrimp in dense swarms. These shrimp are blind, but they have a specialized organ on their backs that can see the thermal radiation, the heat glowing from the vent openings, allowing them to navigate without being boiled alive. There are fish like the eel-like zorsid fish that graze on the bacterial mats and smaller crustaceans. There is even a snail, the scalyfoot snail, that has evolved a suit of armor unlike anything else on Earth. Its shell is coated with iron sulfides, and its foot, the soft, fleshy part it moves on, is covered in hard, mineralized scales made of the same material. It is literally a snail in shining, black iron armor, perfectly adapted to its metallic, sulfurous world. The discovery of these hydrothermal vent communities in 1977 by scientists in the submersible Alvin was a watershed moment in biology. It proved for the first time that life did not depend solely on the sun. It demonstrated that life could thrive in total darkness under crushing pressure and powered by the raw geothermal energy of the planet itself. It opened up the tantalizing possibility that life could exist in similar environments elsewhere in our solar system, perhaps in the subsurface oceans of moons like Europa or Enceladus. This second secret, this oasis of fire and poison, is a profound lesson in tenacity. It shows us that where there is energy, no matter its form, life is ingenious enough to find a way. The ghost of the abyss. Let's pull away from the searing heat of the vent and ascend once more into the vast, open water of the midnight zone. This is a realm defined by its emptiness. There are no surfaces to hide behind, no seafloor to rest upon. It is just water, endless and black. In an environment like this, with few places to hide, one successful evolutionary strategy is to become very, very big. This phenomenon, known as abyssal gigantism, is the ocean's third great secret. And there is one creature in particular that embodies this secret, a creature that has fueled myths and legends for centuries, the giant squid. For most of human history, the giant squid Architeuthis dux was pure legend. It was the kraken of Norse mythology, a beast large enough to pull entire ships down to their doom. Our only evidence of its existence was circumstantial. Enormous, rubbery carcasses would sometimes wash ashore after storms, often mangled and incomplete. Whalers would find massive, indigestible beaks like that of a monstrous parrot inside the stomachs of sperm whales. And most tellingly, the bodies of these great whales were often covered in scars, circular wounds, sometimes lined with small serrations left by the suckers of a colossal opponent they had grappled with in the darkness. The evidence pointed to a true monster of the deep, but for the longest time, no one had ever seen one alive in its natural habitat. It was a ghost. That all changed in the modern era of deep-sea exploration. After years of trying, the first photographs of a living giant squid were finally captured in 2004 by Japanese researchers, and the first video was filmed in 2012. These encounters confirmed that the legend was real and gave us a glimpse into the life of this incredible animal. Let's imagine we are lucky enough to have such an encounter now. We are drifting silently, our lights dimmed, to avoid startling the local inhabitants. Our sonar operator signals something large approaching. We turn our main lights on, and there, materializing out of the gloom, it is. The sight is both terrifying and magnificent. A creature the length of a school bus hangs suspended in the water before us, its body a massive, muscular torpedo of pale, reddish skin. This is the mantle, and it contains all the squid's vital organs. At the front, two eyes stare back at us. And what eyes they are! They are the largest eyes in the entire animal kingdom, reaching up to 12 inches in diameter, the size of a dinner plate. These enormous liquid black orbs are not for seeing in color. They are designed for a single purpose: to gather the maximum amount of light possible in a world where light is scarce. They can detect the faintest flickers of bioluminescence from potential prey, or, more importantly, they can spot the dark, looming silhouette of their one great predator, the sperm whale, against the slightly less dark water above. From the base of its body erupts a crown of 8 thick arms, writhing and covered in powerful suckers, each lined with a chitinous, toothed ring that helps it grip its prey. But it's the other two appendages that are truly spectacular. These are its two feeding tentacles, much longer and thinner than the arms, that can shoot out with explosive speed to snatch a fish or another squid from the water. At the very end of these tentacles are flattened, club-like pads covered in a dense arrangement of those same toothed suckers. It is a highly efficient long-range killing machine. We watch as it propels itself with a silent, eerie grace, taking in water into its mantle cavity and then expelling it through a flexible funnel called a siphon. By pointing the siphon, it can move forward, backward, or sideways with remarkable agility. It is a creature of pure fluid power. The giant squid is not even the heaviest squid in the sea. That title belongs to its even more mysterious cousin, the colossal squid, Mesonicoteuthis hamiltoni, which lives in the frigid waters around Antarctica. While it may be slightly shorter than the giant squid, it is much heavier and bulkier with an even larger mantle, and its armament is arguably more fearsome. Instead of just toothed suckers, the clubs on its tentacles are equipped with a terrifying array of sharp, swiveling hooks. It is a true heavyweight brawler of the deep. The battles between these giant cephalopods and the sperm whale are among the most epic predatory struggles on our planet, yet they occur in total darkness miles below the surface, completely unseen by human eyes. A sperm whale, the largest toothed predator on Earth, uses its powerful clicking sonar to locate a squid in the abyss. It dives, sometimes for over an hour, to hunt it down. The squid, with its massive eyes, may see the whale coming and attempt to flee, but if caught, it will fight back, wrapping its arms and tentacles around the whale's head, its toothed suckers and hooks gouging deep into the whale's skin. The whale, in turn, will try to drag the squid up from the crushing pressure of its home environment while trying to bite and tear it with its powerful jaws. We can only imagine the silent, titanic struggle, a wrestling match between titans in the eternal night. More often than not, the whale wins, but the scars it carries for the rest of its life are a testament to the power of its opponent. And the giants don't stop with squid. We might also catch a glimpse of the giant isopod, a creature that looks like a common woodlouse or roly-poly, but magnified to the size of a small dog. It's a scavenger, crawling slowly along the seafloor, feeding on the carcasses of whales and fish that drift down from above. They can survive for years without a meal, a useful adaptation in a world where food falls are unpredictable. Or perhaps we might see the Japanese spider crab, the largest of all arthropods, with a leg span that can reach over 12 feet from claw to claw. They stride across the seafloor on their impossibly long legs like spindly alien walkers. These giants are a product of their environment. The cold temperatures slow down their metabolism, allowing them to live longer and grow larger. The immense pressure and the three-dimensional nature of the water column also play a role that scientists are still working to fully understand. This third secret, the secret of the giants, is a humbling one. It reminds us that our land-based perspective is limited. In the vast, dark and open world of the deep ocean, the rules are different, and life has risen to a scale that dwarfs our own and fires our imagination. They are the living sea monsters of our oldest stories. The crushing weight of the Hadal Zone. There is a place deeper than the abyss, a place whose name is derived from Hades, the underworld. It is the Hadal Zone, the deepest and least explored region of our planet. These are the ocean's trenches, immense scars in the seafloor that plummet to depths so extreme they defy easy comprehension. Our journey now takes us to the most famous of these, the Mariana Trench in the Western Pacific, and to its very deepest point, a small crescent-shaped valley known as the Challenger Deep. As we begin our final descent, the world outside our viewport becomes a place of pure theory. The numbers on our depth gauge climb relentlessly, 8,000 meters, 9,000, 10,000. The weight of the water above us is now a physical presence, a force of nature that feels malevolent in its intensity. The pressure here is over 1,100 times greater than at the surface. Let's try to visualize that. It is the equivalent of placing the weight of 50 jumbo jets on the back of your hand. It is a force that can compress steel and warp the very fabric of matter. Our submersible is a technological marvel, a tiny, reinforced titanium sphere built to withstand a force that nothing organic should be able to survive. It is humanity's finest armor against the awesome power of the planet. For a long time, it was assumed that this was a dead zone, a sterile, pressurized void where life was simply impossible. The first humans to ever visit this place were Jacques Picard and Don Walsh in the bathyscaphe Trieste in 1960. As they touched down on the fine silty bottom, nearly 11,000 meters, 7 miles down, They looked out their tiny, thick viewport and saw something that shocked the scientific community. A flatfish, something like a sole or a flounder, swimming peacefully away. While later analysis suggested they may have seen a sea cucumber, the point was made: life was here. The fourth secret of the ocean is that even in the most hostile, most alien, and most crushingly violent place on Earth, life finds a way to endure. Reaching the bottom of the Challenger Deep feels like landing on another world. The sea floor is not rock, but a fine, pale, almost sticky sediment. This is foraminiferal ooze, the accumulated, compressed remains of countless trillions of tiny, single-celled plankton that have lived and died in the waters miles above, their microscopic shells snowing down over millions of years to form the very ground we rest upon. It is a seabed made of ghosts. And crawling on this seabed of ghosts are the living. In 2012, filmmaker and explorer James Cameron made a solo dive here in his vessel, the Deepsea Challenger. In 2019, explorer Victor Vescovo completed the first of many dives in his submersible, the Limiting Factor, opening up a new era of Hadal exploration. These missions, equipped with high-definition cameras and robotic arms, have revealed a surprisingly active community. We see herds of small, shrimp-like crustaceans called amphipods, but here, in the trench, some of them are supergiants, growing over a foot long, their bodies are a ghostly, pale white. They are the vultures of the deep, swarming any bait package or potential food source that reaches the bottom. We see xenophyophores, one of the unsung wonders of the deep. They look like strange, flattened sponges or fossilized lichens, but they are, in fact, the largest single-celled organisms on Earth. A single xenophyophore can grow up to 10 centimeters across, a giant composed of just one cell with multiple nuclei that builds its intricate shell-like structure called a test by gluing together minerals and sediments from the seafloor. They are the architects of the Hadal Plains. And then there is the undisputed king of the Challenger Deep, the Mariana snailfish. Discovered only recently, this small tadpole-shaped fish is a true miracle of adaptation. It's pinkish-white, almost translucent, and it has no scales. It looks incredibly delicate, like something that would fall apart if you touched it. Yet it is the deepest living fish ever discovered, thriving under pressures that would turn any other vertebrate to pulp. How does it survive? Its body is a masterpiece of biochemistry. Instead of firm muscles and rigid bones, it is largely gelatinous. Its skeletal bones are not fully calcified. They are made of flexible cartilage, allowing them to bend rather than break under the immense pressure. Furthermore, its cells are filled with special molecules called piezolites, from the Greek word piezin, to press, that bind to water and proteins, preventing the cell membranes and enzymes from being crushed and distorted by the extreme pressure. It doesn't fight the pressure, it yields to it, incorporating the force of the ocean into its very being. It swims with an eerie, ribbon-like grace, the top predator in the deepest place on Earth. But these modern expeditions have revealed another, more sobering truth about the Challenger Deep. When Victor Vescovo landed on the bottom, one of the first things his camera saw was a plastic bag. Analysis of the amphipods brought back from the trench has shown that their bodies are filled with microplastics and industrial chemicals that have worked their way down from the surface world. This is perhaps the most profound part of the fourth secret. This place, the most remote and inaccessible on the planet, is not pristine. Our human footprint is already here. There is no corner of the ocean, no matter how deep or dark, that is now untouched by our influence. The discovery of life here is a miracle of adaptation, but the discovery of our trash is a solemn warning. We are connected to this deepest, darkest place in ways we are only just beginning to understand. The faces in the dark. Let's ascend from the crushing depths of the trench back up to the realm we call the Bath-I pelagic zone, or the midnight zone. It's a world of perpetual twilight and darkness, roughly between 1,000 and 4,000 meters down. While it may lack the searing energy of the vents or the sheer pressure of the Hadal zone, this region holds a secret that is, in many ways, the most visually arresting and creatively unsettling. This is the secret of bizarre and monstrous beauty. Life in this zone is a gallery of evolutionary masterpieces, creatures so strange, so perfectly adapted to their unique challenges that they seem to have been sculpted by a brilliantly imaginative and slightly deranged artist. These are the faces in the dark. The challenges here are immense. There is no sunlight for photosynthesis, so the entire food web is based on what falls from above, a slow, constant drizzle of organic matter known as marine snow, or on eating your neighbors. Food is incredibly scarce. To survive, you must be ruthlessly efficient. Every ounce of energy counts, and you must be able to find and consume a meal that might be the only one you get for weeks, or even months. These pressures have resulted in some of the most fantastical body plans on our planet. Let's dim our lights and see who emerges. There, a flicker of silver. It's a hatchet fish. We saw it before, but let's look closer. Its body is impossibly thin and compressed, like a coin stood on its edge, with the reflective, silvery skin that makes it difficult to see. Its most prominent features are its two large tubular eyes, which are permanently fixed, looking straight up. In a world where food drifts down from above, looking up is the most logical thing to do. The hatchetfish spends its life scanning the sky above it for the faint silhouette of a copepod or a small crustacean against the barely perceptible light from the surface world miles away. Its mouth is also upturned, perfectly positioned to snatch anything it sees. As we discussed, its belly is lined with photophores for counter-illumination, making it a master of stealth. It is an animal that has been completely shaped by the concept of up. Now something else drifts into view. It looks less like a fish and more like a floating nightmare. This is the fang-tooth Anaplagasta cornuta. Relative to its body size, it has the largest teeth of any fish in the ocean. They are like translucent daggers. In fact, its lower fangs are so long that it cannot close its mouth in the normal way. Instead, it has two special sockets or pouches on either side of its small brain, where the tips of these fangs slide in when its mouth is shut. Despite its terrifying appearance, the fang-tooth is actually quite small, usually only about 6 inches long, and it's mostly blind. It doesn't hunt by sight, but by touch and chemical cues. It has a well-developed lateral line system that can detect the faintest vibrations in the water around it. It essentially bumps into its prey in the dark, and its huge teeth ensure that once it bites something, it does not escape. Let's wait a moment. What is that long, black ribbon undulating in the distance? As it gets closer, we realize it's an eel, but one unlike any you have ever seen. This is the gulper eel, or pelican eel. This creature is, for all practical purposes, a swimming mouth. Its jaw is gigantic, loosely hinged, and can open to a size that seems anatomically impossible, allowing it to swallow prey much, much larger than itself. The lower jaw is like a huge fleshy net or pouch. When a fish or large crustacean blunders into its path, the eel's mouth flares open and its stomach can stretch to accommodate the massive meal. It's a low-energy hunting strategy. Don't waste energy chasing food. Just be ready for the rare occasion that food comes to you. Trailing behind its body is a long, whip-like tail, and at the very tip is a complex photophore, a light organ. It can flash this light, perhaps to use as a lure, waving its tail in front of its own face to draw prey toward its waiting, cavernous mouth. And there, a true demon of the deep, the viperfish. It's a long, slender fish with metallic-looking scales, but its defining feature is its jaw. Like the fangtooth, it has enormous needle-like fangs. The fangs on its lower jaw are so long they curve back up over its head, well past its eyes. Its jaw is hinged, and its entire skull can rotate upward to allow it to swallow its victims whole. Its first vertebra is even specially modified to act as a shock absorber for when it rams its prey. The viperfish doesn't just wait for food, it hunts. It has rows of photophores along its belly and a lure on a long dorsal spine, much like an anglerfish, which it dangles in front of its mouth to attract its victims. Perhaps the most surreal creature we might encounter is the barrel-eye fish, Macropinna microstoma. At first, it looks relatively normal, if a bit plain, but then you notice something extraordinary. The top of its head is completely transparent, a fluid-filled dome. Inside this clear canopy, you can see its internal eyes. They are two bright green barrel-shaped lenses, and they are typically pointing straight up, just like the hatchet fishes. But here is the incredible trick. The barrel-eye can rotate its eyes. It can look straight up to spot prey, and then as it moves in to eat, it can rotate its eyes to look straight forward to guide the food into its small mouth. It is the only vertebrate known to have this ability. The transparent shield protects its sensitive eyes, likely as it steals food from the stinging tentacles of siphonophores. It is a design so alien, so unexpected, that when it was first described from mangled net-caught specimens, scientists didn't even realize its head was transparent, misidentifying two olfactory spots on its snout as its eyes. These creatures, these beautiful monsters, are the fifth secret. They are a testament to the sheer, unbounded creativity of evolution. In a world of darkness, scarcity, and pressure, life has not just survived, it has become art. Strange, terrifying, and profoundly beautiful art. Each one is a perfectly solved puzzle, a living sculpture that tells a story of survival against all odds. The soundscape of the abyss. Let's kill our engines completely. Let the gentle hum of our submersible fade away, along with the soft hiss of the air scrubbers. Let us just float here in the infinite black and do something that seems counterintuitive. Let's listen. You might think that the dominant feature of the deep ocean is its darkness and its silence. The darkness is real, but the silence is an illusion. The sixth secret of the deep is its soundscape. This is a world that is not silent, but is, in fact, filled with a rich and complex symphony of sounds that travel for astonishing distances, carrying messages of life, death, and the very groaning of the planet itself. In the abyss, sound is a far more effective sense than sight. Light is absorbed and scattered by water very quickly, but sound, especially low-frequency sound, can travel for hundreds even thousands of miles. This is thanks to a remarkable feature of the ocean known as the SOFAR channel, which stands for Sound, Fixing and Ranging. It's a horizontal layer of water typically found at a depth of around 1,000 meters, where the speed of sound is at its minimum. The temperature, pressure and salinity at this depth create a perfect conduit. Any sound made within this channel that tries to travel up is refracted back down by the warmer, higher pressure water above. Any sound that tries to travel down is refracted back up by the colder, even higher pressure water below. The sound waves are effectively trapped in this channel, able to propagate across entire ocean basins with very little loss of energy. It is the ocean's own natural fiber optic cable, but for sound. The great composers and performers in this underwater orchestra are the great whales. The sounds they make are not just random noises, they are some of the most complex and powerful acoustic signals in the animal kingdom. Let's imagine we can hear them now, that deep, resonant, an incredibly loud moan that seems to vibrate through the very hull of our submersible is the call of a blue whale. These are the loudest sounds made by any animal on Earth, reaching up to 188 decibels. They are so powerful and of such a low frequency that they can travel clear across an entire ocean. A blue whale off the coast of California can, in theory, communicate with another whale off the coast of Japan. Scientists believe these calls are used for long-distance communication, for navigating the vast, featureless expanse of the open ocean, and for finding mates. Then there are the songs of the humpback whales. These are not simple calls, but long, complex and structured songs with repeating themes and phrases, much like human music. The songs can last for over 20 minutes, and the whales will repeat them for hours. What's truly fascinating is that all the males in a single population will sing the exact same song. But the song is not static. It evolves over time, with new phrases being added and old ones being dropped. And if one population comes into contact with another, they can learn and adopt the new, more popular song. It is a form of large-scale cultural transmission, a hit single that can sweep across the entire Pacific Ocean in a couple of years. We might also hear the rapid, powerful clicks of a sperm whale. These are not communication calls, this is echolocation. The sperm whale has the most powerful natural sonar system on the planet. It uses its massive head filled with a waxy substance called spermaceti to focus and project these clicks into the abyss. The clicks bounce off objects in the darkness, a canyon wall, a school of fish, or its favorite prey, the giant squid, and the returning echo paints a detailed sound picture of the world in the whale's mind. It is how the whale sees in the total darkness where it hunts. But the symphony is not just biological, the earth itself adds to the chorus. The groans and creaks of shifting tectonic plates, the deep rumble of a distant underwater earthquake, and the hiss and crackle of a new hydrothermal vent being born, all contribute to the low-frequency background noise. For years, oceanographers using a network of underwater hydrophones have recorded mysterious, powerful sounds that have defied easy explanation. The most famous of these was the bloop, an extremely powerful, ultra-low-frequency sound recorded in 1997 in the South Pacific. It was so loud and of such a strange character that for years it fueled speculation that it might have been made by a colossal, unknown marine animal, something far larger than a blue whale. The mystery was a thrilling one, but it was eventually solved. Scientists now believe the bloop was the sound of a massive icequake, a huge iceberg cracking and breaking away from the Antarctic ice shelf. The sound of the planet's ice breaking under the strain of a changing climate. And now a new dissonant sound has been added to the symphony: us. In the last century, we have filled the oceans with our own noise. The constant, low-frequency hum of thousands of container ships crossing the globe, the loud pings of military and commercial sonar, and the explosive blasts from seismic air guns used in oil and gas exploration have created a form of acoustic smog. This anthropogenic noise can interfere with the ability of marine animals to communicate, to navigate, and to find food. It can cause whales to become stranded and can cause physical injury to their hearing. This is the troubling part of the sixth secret. The sacred soundscape of the deep is being polluted. We are drowning out the ancient songs with our own relentless noise, making it harder for the inhabitants of this vast, dark world to speak to one another. Listening to the ocean means hearing its beauty, but it also means hearing the damage we are causing. The ocean's slow breath. Our journey is almost over. It is time to begin our long, slow ascent back to the surface, back to the world of air and light. As we rise, let's reflect on one final secret. This one isn't a creature or a place or a phenomenon. It's a concept, perhaps the most important one of all. It is the secret of deep time, of the ocean's slow, deliberate breath, and of its profound and terrifying fragility. Life in the deep moves at a completely different tempo than life on land. The environment is incredibly stable, the temperature is consistently cold, the darkness is constant, and the seasons do not exist. But it is also a world of low energy. Food is scarce, and every calorie must be conserved. As a result, the metabolism of deep-sea creatures is incredibly slow. They grow slowly, they move slowly, and they live for a very, very long time. Consider the Greenland shark, a large, sluggish creature that patrols the deep, cold waters of the North Atlantic. For a long time, its lifespan was a mystery. But recently, scientists developed a way to date them by analyzing the proteins in the lenses of their eyes, which are formed before birth and do not change throughout their life. Using radiocarbon dating on these proteins, they made a staggering discovery. The Greenland shark is the longest living vertebrate on the planet. They can live for at least 400 years and possibly more than 500. A shark swimming today could have been born before the signing of the Declaration of Independence. It has lived through the Industrial Revolution, 2 world wars, and the entire digital age, all while swimming silently in the cold darkness. This incredible longevity is not unique. The rough-eye rockfish, a bright orange fish that lives off the Pacific coast, can live for over 200 years. And even these are youngsters compared to some of the stationary life. Deep-sea corals, which look like delicate, barren trees, grow at a glacial pace, sometimes only a few micrometers a year. A large, branching colony of black coral can be thousands of years old. In 2009, scientists studying gold corals in the deep waters off Hawaii found one that was dated to be 4,265 years old. It was a living animal that began its life around the same time the Great Pyramids were being built in Egypt. These creatures are not just animals, they are living, breathing records of ancient history. They are the oldest living things on our planet. This is the first part of the secret. The deep is a world of ancient life and slow time. But this very nature leads to the second, more urgent part, its extreme fragility. An old-growth forest on land, if cut down, might begin to recover in a few hundred years. But a deep-sea coral garden, thousands of years old, if destroyed by a deep-sea fishing trawler, will not recover in any human timescale. It is gone forever. The giant, slow-moving Greenland sharks, if overfished, cannot replenish their populations quickly. A species that takes over a century just to reach sexual maturity cannot withstand the industrial pressures of modern fishing. The slow, patient rhythm of the deep is no match for the frenetic, destructive pace of the world above. And this brings us to the ultimate connection, the part of the secret that ties everything together. The deep ocean is not a separate world. It is the flywheel of our planet. It is our planetary life support system. The ocean has absorbed over 90% of the excess heat that our civilization has pumped into the atmosphere from burning fossil fuels. This has buffered us from the worst effects of climate change, but it has come at a cost. The oceans are warming from the surface to the abyss. This warming changes currents, affects the distribution of life, and can lead to a decrease in oxygen levels. Furthermore, the ocean has absorbed roughly a third of all the carbon dioxide we have emitted. This also has a chemical cost. When CO2 dissolves in seawater, it forms carbonic acid, a process known as ocean acidification. This other CO2 problem is making the water more acidic, which makes it harder for creatures like corals, clams and tiny plankton to build their vital calcium carbonate shells and skeletons. The very foundations of the oceanic food web are being corroded by the waste products of our civilization. This is the final, most humbling secret. The deep ocean, this remote alien world we have just visited, is intimately and inextricably linked to us. Its health is our health. Its slow, deep breath is the very breath of our planet. We have explored its wonders, from the living light to the fiery vents, from the ghostly giants to the beautiful monsters. We have seen its resilience and its raw power, but we have also seen its fragility and the scars we have already left upon it. As we finally break the surface and the brilliant, warm sunlight floods our viewport once again, the world outside looks the same. But we are different. We carry the secrets of the deep within us now. The knowledge that our planet's greatest realm is not an empty void, but a living, breathing, and vulnerable world. A world that has existed in serene darkness for eons, and a world that is now asking for our help. The journey is over, but the responsibility has just begun. Thank you for listening. Now you can rest and not worry about the scary depths of the ocean. Good night.